At the height of the Cold War, when a single photograph could change the course of history, the United States built an aircraft so advanced that even today it feels unreal. It flew higher than any fighter, faster than any missile, and so deep into enemy territory that no defense system could stop it. This aircraft was not meant to fight. It was meant to see everything. This was the State Route 71 Blackbird. The Blackbird was born from escalating tensions with communist nations in Eastern Europe, during a time when intelligence meant survival. Satellites were still limited, slow, and predictable. What the United States needed was an aircraft that could outrun danger itself. That task fell to Lockheed Martin's Skunk Works, an ultra-secret division of engineers and scientists whose job was to solve problems no one else dared to attempt. From the very beginning, the State Route 71 challenged the laws of aviation. Flying at more than 3 times the speed of sound and above 85,000 feet, it faced temperatures and aerodynamic forces that would destroy conventional aircraft. Aluminum would soften, steel would fail. The solution was titanium, lightweight, incredibly strong, and resistant to extreme heat. But there was a problem. The best titanium in the world came from the Soviet Union. In one of the greatest ironies of the Cold War, the CIA created front companies to secretly buy the metal from the very nation the Blackbird was built to spy on. The State Route 71 also incorporated some of the earliest stealth concepts ever used. Its black paint absorbed radar energy and helped dissipate heat. Its sharp, angular shape reduced its radar signature, allowing it to slip through heavily defended airspace. Speed, altitude, and invisibility became its armor. The first flight took place on December 22, 1964, in Palmdale, California, with Lockheed test pilot Robert J. Bob Gilliland at the controls. From that moment on, aviation would never be the same. For more than 2 decades, the State Route 71 flew missions across the globe, photographing targets far beyond the reach of satellites. Inside the cockpit, 2 crew members worked in perfect coordination. One flew the aircraft. The other operated high-resolution cameras and reconnaissance systems capable of capturing images from hundreds of kilometers away. Despite flying through the most dangerous airspace on Earth, no State Route 71 was ever lost to enemy fire. But the true miracle of the Blackbird was not just its airframe. It was what powered it. The State Route 71 was equipped with 2 Pratt and Whitney J58 engines, machines that, when introduced in the late 1950s, appeared almost alien by the technological standards of the time. The J58 was not a conventional jet engine. It was, in essence, 2 engines in one, a turboramjet. During takeoff and acceleration up to Mach 2, the J58 behaved like a traditional jet engine. Air entered the intake, was compressed, mixed with fuel, ignited, and expelled to generate thrust. But beyond Mach 2, as the Blackbird pushed toward its cruising speed of Mach 3.2, everything changed. At those extreme velocities, incoming air was violently compressed and heated by the engine inlet and ducting, creating powerful shock waves that slowed the airflow from supersonic to subsonic before it even reached the compressor. About 20% of that air was then diverted after passing through part of the compressor and routed directly into the afterburner through 6 specialized bypass tubes. The remaining air continued deeper into the engine, passing through additional compressor stages, where it was further compressed. Fuel was then injected into the combustion chamber, and the mixture passed through the turbine. After that, it reunited with the bypassed air inside the afterburner. At speeds approaching 3 times the speed of sound, the engine and incoming air became so hot that less fuel was required. The turbine could not tolerate higher temperatures, so mechanical power decreased. The rotating parts of the engine produced less energy, yet they still spun fast enough to keep air flowing into the engine. At these speeds, the rotating machinery inside the engine actually created drag, slightly slowing the aircraft. The Blackbird maintained its velocity not through mechanical thrust alone, but through the immense thermal energy generated in the afterburner. In simple terms, heat itself became propulsion. There was only one true limitation: temperature. The maximum allowable inlet air temperature for sustained operation was 430 degrees Celsius. Exceed that, and the engine materials could begin to fail. This meant the Blackbird's ultimate speed limit was not defined by power, but by physics. In colder air, or at higher, colder altitudes, the State Route 71 could safely fly much faster than its official limits. Officially, the Blackbird's cruising speed was Mach 3.2. Unofficially, reality was more complicated. In April 1986, during a reconnaissance mission over Tripoli, Libya, and State Route 71 piloted by Brian Schul came under threat from surface-to-air missile launches. Increasing speed had not been part of the pre-flight plan, but it quickly became the only option. As missile launches were detected, Schul accelerated. And then accelerated again. His reconnaissance systems officer eventually warned him that they were exceeding Mach 3.5, more than 3.5 times the speed of sound. What mattered most was not the speed, but the engine readings. Temperatures remained within safe limits. That meant one thing: if absolutely necessary, the Blackbird could have gone even faster. Throughout its service life, the State Route 71 proved its dominance repeatedly. In 1968, it began operational missions over Southeast Asia. In the 1980s, Blackbirds based in the United Kingdom monitored Eastern Europe. In 1987, flights from Kadena Air Base exposed Iranian Silkworm missile batteries in the Persian Gulf, protecting commercial shipping and U.S. naval forces. The aircraft also shattered records. Lieutenant Colonel Ed Yelding and his reconnaissance systems officer, Lieutenant Colonel Joseph Vida, flew in State Route 71 from Los Angeles to Washington, D.C. in just 1 hour, 4 minutes, and 20 seconds, breaking 4 national speed records along the way. After landing, that aircraft was retired and placed in the National Air and Space Museum, where it remains today. After its military retirement in 1990, the Blackbird continued serving science. NASA operated 2 SR-71s between 1990 and 1995, using them as high-speed research platforms. The data collected helped shape future supersonic aircraft and advanced propulsion systems, including concepts for high-speed civilian transport. In 1991, NASA engineer Martha Bonemeyer became the first woman to fly aboard the State Route 71. Following a brief reactivation, the U.S. Air Force permanently ended the State Route 71 program on June 30, 1999, at Edwards Air Force Base in California. The final flight took place on October 9, 1999, when SR-71A serial number 61 to 7980 soared one last time before a crowd at the Edwards Air Force Base open house. The State Route 71 Blackbird remains one of the greatest achievements in aerospace history. A machine so advanced that its true limits may never be known. Designed nearly 65 years ago, it still stands unmatched, faster than fear, higher than war, and decades ahead of its time.